Hello, welcome to this section in the chemistry tutor. We're going to conclude our discussion of partial pressures with a couple of quick problems here. These really aren't any harder than what we've done before, but they just give you a little more variety. So the first problem says a mixture contains hydrogen gas at 325 torr of pressure, nitrogen gas at 475 torr of pressure, oxygen gas at 650 torr of pressure. What is the total pressure in the system? It sounds like a really trivial and simple thing, and in some cases it is, but really the problem has given you essentially the partial pressure of hydrogen, and it's also given you the partial pressure of oxygen, and it's also given you the partial pressure of the nitrogen. So the total pressure of the system, P total, is basically the partial pressure of gas 1 plus the partial pressure of gas 2 plus the partial pressure of gas 3, and all three of these are given to us. So 325 plus 475 plus 650. And when you add all these guys together, you get 1,450 torr. And that is the answer. So again, very, very trivial, but again, it's illustrating what a partial pressure is. So I think it's important for you to see problems of all types. Now this one is a little bit trickier. It's not trickier, really super tricky or hard, it's just different, okay? What is the pressure in atmospheres of a gas mixture of 1 gram of hydrogen gas and 8 grams of argon gas in a 3-liter container at 27 degrees Celsius, 27 degrees Celsius. So they want to know not the partial pressures, they want to know the total pressure. But you also have to remember that the total pressure in a vessel is the sum of the partial pressures. And we've already said that each individual gas in a mixture obeys the ideal gas law individually, okay? So if we can use PV is equal to nRT for each gas individually and find the partial pressure of each one of these gases, in this case hydrogen and argon, then all we have to do to find the total pressure is to add those partial pressures together.